So a question first, like, how many people here actually maintain an open source project? How many people have wanted to rage quit their open source? Yeah, me too. It seems to be the kind of like general term when it comes to you get to this point where you kind of just really don't want to deal with your project anymore, and then something happens. Like for me, they started paying me to do it, and now I have to do it because it's the way I get food on the table. So how did I get into? Oh, that was really fast. How did I get into Node.js? So I was actually at RubyConf here in Berlin in like 2000 and was it like 2009 or something like that? Yeah, something like that. No, 2007 actually. And we were talking about I think V8 had just been announced, and it was like all over the internet and stuff. And I was talking with a friend, and I was like, "So, how long do you think it's going to take before somebody writes a JavaScript framework, right, for the server?" And I was like, "I don't know, but it's going to be cool, right?" And I did a little thing, put up a Google alert, and like I think it was like a little bit later, like nearly 2 years later, suddenly my Google alert went off and said like, "Hey, Node.js is out." And I was like, "Oh, look, it's JavaScript on the server." But it's not exactly what I expected from coming from Ruby. I was like, asynchronous, huh? Right? So that was like the big shock, and I got intrigued, right? And I decided to like start playing around with it and wrote my own little applications. And I came to a time where I basically need to store some data somewhere. And at that point, there was only Ryan's PG JavaScript script that was like a simple Postgres driver. It wasn't really fast. It wasn't really any particularly full-formed platform at that point. And I was kind of looking around, and a friend of mine, a Ruby guy, had been using MongoDB down in Atlanta for a project, and said, like, "Why don't you use this? It's like JSON, right?" And so I said, like, "Okay, let me write my own driver, since you basically have to do everything yourselves at this point," because I don't know how many people were in the Node community at that time, but a couple of hundred maybe. So after a couple of months, the first commit was out, and like January 7th, 2010. And since then, it's just been crazy, all right? And specifically, last year, in the last 12 months, like the growth in usage for Node.js projects in general, or NPM modules, has just exploded, right? MongoDB is kind of like an exception. Like, I mean, we've gone from like about 20,000 NPM installs to about like 200,000 a month or something like that. I think Socket.io, I think Redis is probably the biggest one. I think it's got about 400,000 installs a month. But it's just gone gangbusters. And I kind of expect this trend to keep going in the next couple of years. So how was the first driver when it came out? It was a total piece of shit. All right? So it had things like a hash and an ordered hash class that I had written because I was relying, I didn't want to rely on the behavior of V8 and ordering keys. And it was a complete horrible structure mess. Like, it was just me learning to write JavaScript, basically. And there wasn't really any testing frameworks at that point, so I had to kind of hack up JSpec to make it work so I could have some testing framework. The other thing was like Node was like liquid water, right? Everything was constantly changing. Like from one point release to the other, like philosophies would change, right? So I don't know how many people here love promises, but that was initially in Node, and then they took it out. I don't remember exactly what the reason was, but it was taken out. And yeah, there was no NPM at that point at all, right? So everything you did, you basically had to kind of download JS and put it in the right directories yourself and stuff like that. So there was no real way of distributing the driver either. People just had to basically clone your Git repository and use the driver. So the kind of challenges you kind of run into when you're writing something like a driver in JavaScript. No int64 support. I was just in a JavaScript crypto talk here, and he said that he mentioned that there's a WW3 crypto library or crypto API may be coming that might have int64s. That would be a revelation for me. But the problem, and this is something you're going to run into eventually as a JavaScript developer, is that the numbers aren't really numbers. They're actually floats, right? They're double floats, which means that anything over 53 bits cannot be represented as a whole integer. In fact, when you reach that number, it just keeps being the same number over and over and over again, right? So to represent 64-bit ints, which we need to support all of the MongoDB kind of types, you had to use the Google long closure library. And that works pretty well. It's a bit slow, because you have to do all this 64-bit arithmetic over two 32-bit values, but it works. But that was a pain. So then we started kind of adding features, because I was sort of evolving the driver as MongoDB itself was adding features. So we had to add gridfs, which is like storing files in the database. They came up with like clustering, which is called Replicasets in MongoDB, and then later sharding, and so I had to add support for that. And then adding streams, support for cursor and gridfs when that became kind of like the big meme in Node.js, and it kind of became more standard. And dealing with complicated issues like high availability. Then after a while, you know, like you get into this more, I want to like optimize stuff, and the C++ APIs had finally kind of like solidified enough for you to go and write a C++ extension. And there was actually enough tutorials of people actually had tried at that point. So I decided to profile the application and then look at like where the hotspot in the code was. And at that point, the whole parser was JavaScript. And it was actually, the bottleneck was the parser, right? So I wrote a horrible C++ parser, because I'm not a C++ person. Thankfully, there was a guy in LucasArts, may they rest in peace, that cleaned up the code later. And now I think it's a fairly solid parser. A couple of things that I did wrong was that, for example, the initial version implemented these types that are in MongoDB, like a binary class or a long type, or this kind of stuff, re-implemented in C++. And that was just hard as hell to maintain, right? There was like, every time somebody sent me a bug fix for something, like I had to go back in C++ and fix that code as well. And in the end, it didn't mean anything. There was no performance benefit there at all, because in the end, it wasn't expensive to actually instantiate just JavaScript classes inside of V8 C++ code and just use those. So now the parser, the C++ parser, just deals with the actual parsing, but it's still just using the JavaScript objects for the types, which means I don't have to maintain as much code. Then, like, as Node.js was liquid, suddenly they introduced buffers, right? And buffers was like a massive improvement, right? Also because the Google V8 team, Weislav and these guys, actually went out of their way to make it be fast for Node.js. So one of the things you kind of have to do with buffers, like for example, is to be aware that like allocating buffers can be expensive. And so when you're doing something like a BSON serialization, you have to allocate some sort of binary buffer of some particular size. The way MongoDB documents are nested documents, you kind of have to walk the tree to determine the size of the final buffer. And it's actually faster to iterate through the entire tree, allocate once a big piece of slab of memory, serialize into that memory, and then write it out, than to try to basically, you know, plug a bunch of smaller buffers together. Because the cost of allocating all those small things is quite expensive. Actually, in fact, like one of the experiences I'm considering is just to allocate the maximum size of BSON I can do and just use that buffer again and again all the time and just never actually allocate any memory other than once. So I think that might be able to get the JavaScript version up to C++ speed. So one of the things you have to know about buffers is that they have a secret optimization in V8. So if you ever do like profiling in Node.js, you're going to see these things called slow buff and fast buff show up. And fast buff basically lets you map directly into memory. So if you do something like entry, if the buffer is called A, element 0, and then set it to a byte value, it actually will go straight into memory instead of going through the entire stack of V8. So that's also based on what type arrays do. So type arrays are equivalent in this respect to like buffer performance-wise. That said, I don't know if eventually buffers might even go away or be implemented just on top of existing type arrays, but that's something to ask from the Node.js people. The other thing you have to deal with is like pool handling. So when you're a database, you've got lots of connections, you have to check in stuff, check it out. You can't really do that in an efficient way in Node.js because blocking isn't really an option, right? So Spice must flow. Also, in MongoDB, you basically have this situation called a write concern. So traditionally, MongoDB basically wrote a message, like an insert, straight to the socket, out to the database. And to actually get the result of that insert, you have to write a second message called getLastError right after, right? So the getLastError and the thing has to happen one after the other, because the socket is bound to a specific thread. So if you put something else in between and then do getLastError, you're basically going to get the result from the operation that happened, but not the one that you wanted. So the thing to do that is, at least Node.js was to pipeline it, right? So you write the op and the getLastError into one single binary buffer and flush it out to the socket. Then we get problems like how to deal with reconnects, right? So you have a cluster, one of the servers disappear. Now you need to reconnect. But MongoDB isn't blocking. Like, so in typical traditional synchronous languages like Python, you might just wait for the server to come back and then block all operations until you're basically ready to write to that server. So Node.js basically, what it does is that in a cluster, when the secondary goes down, it starts buffering up the operations until there is basically an available server, and then it flushes those operations out to that server. So in the best case, what you're going to see is just an increase in latency on your operations, but you're not going to lose any operations. The problem is, obviously, if your service is out long enough, you're going to run out of buffer or memory space, basically. So there's still this kind of balance between one and the other here that I haven't quite figured out. The other thing that people wanted was the ability to kind of just serialize an object, but not necessarily just let the serializer decide which fields were to be serialized, right? So there was a need to this was actually, people came to me and committed part of this code. The idea was just to add something like a to BSON thing. So if you actually have an object and you add a to BSON function, in that function, whatever you return is what gets serialized. So it makes it a little bit easier to kind of make your own kind of semi-ODM style thing where you can kind of keep fields transitive in the documents and not necessarily have to write them to disk. And this was a very simple thing, but that it actually got a lot of use for a lot of people. So we were talking about the fact that we have these clusters on Replicasets. They come and go, right, as server. So you have these secondaries in MongoDB, which are basically slaves in the terminology of normal databases. And you have these problems where you basically have to query once in a while the state of Replicaset to figure out if some new node came into production, right? Because in MongoDB, you can kind of say, I'm going to boot up a new database, and I'm going to add that to this cluster, and the driver needs to be able to pick that up and basically include that as possible server to read from. And in the application itself, you can basically say, let me read from a slave. All my reads should go to a slave and not to the actual master. So this is where the main problem comes with Node.js, right? For this particular use case, a single thread just sucks, right? You can use set time of the set interval, but it's not really that good. It's like a Yankee way of doing it, because there's no there's really, really soft kind of there's very, very, very soft guarantees on set time out of set interval on it running on a specific time. So if you're just hammering your Node.js application with JavaScript, set time out that's set to 1 second might take longer than 1 second. And there's lots of subtle state changes that can happen in between. And I don't think we're ever going to get web workers in Node.js. I hope so, but I'm not holding my breath. And there's not really an option of using processes, because I can imagine a driver that starts spinning off processes without your knowledge. That's probably not going to be a popular driver. And the other thing that I ran into was when Node.js went multi-platform, right? Hello, Windows users. Anybody here is a Windows user? Wow. There's actually a couple of hands. That's amazing. So Node.js goes Windows, right? What about that damn C++, right? Anybody here, you Windows users, enjoy C++ extensions? No. So what you do in this case, like you install a driver, Node-GIP will throw an error. It will still install, but it will throw an error. So you get this confusion going, right? So you build DLLs. In case I built DLLs automatically for Windows 32 and Windows 64, and just package them with the actual driver, so that like if you're on Windows, it will go and look, is there a DLL, load that, and you'll use the C++ parser. But there's all these Yankee things. I've probably improved a little bit, but for example, until recently, you could only build Node extensions using Visual Studio 2010 plus the Windows 7 64-bit SDK. Just finding that out is like a quest in itself. And Node-GIP will basically give an error that the package didn't build, leading to my typical GitHub issues where I cannot install the module because I'm getting an error, right? Even if the module installed. So usually the problem is between the screen and the seats. But sometimes they have a valid point. So one of my biggest pet peeves, I guess, is that I would love to be able to tell Node-GIP, don't build for Windows, right? And then like just have it installed properly, and it ignores basically the build process. And then you have the random people who are still using Windows XP. Like, who the hell uses Windows XP? Seriously. It's like, but it seems to be like, I don't know, it's like there's like a random amount of people who are using it. So after experiencing all the pain of Windows, which is an ongoing hell, basically, so it's never finished, there's something new every couple of weeks. Usually when Microsoft publishes a Node.js article in their MSDN magazine, there's a new flood of people to use Node.js. At least like I had the possibility of working a little bit on other things, right? So one of the things that I really enjoyed was like getting the ARM build to work properly, right? So you can run it on Raspberry Pi. And that was really good fun, and I learned a lot about like how memory alignment is different between ARM and x86. So considering all that, like what kind of regrets do I have when having dealt with this project over 4 years, right? So I think most of the things I really regret is doing this. I don't know if this can be considered an anti-pattern, but it's definitely not good if you're dealing with something like the driver. I should have done this, right? And the lessons from that is really, if it's possible to access the internal state of something, people are going to access the internal state of something. And it's just like getting tickets where people are like, oh, my application doesn't work because I'm using this internal field to find some state of the driver, and that field is no longer there. It's not kind of fun, right? So like the lesson, at least from the perspective of this, is like, I guess it's a global lesson when it comes to APIs, which is like only expose state and functions that you explicitly want the user to use. Now, this was more the fact that I was like completely new to JavaScript, and that was what I started with. So I'm kind of trapped between this situation that I actually have to do backwards compatibility. Drivers are supposed to be one of the most boring things you use. It should just work, right? So changing code that breaks people's applications is a no-no. Other things that I really did bad was like I actually exposed the collection class and I exposed the cursor class, leading people to create instances of these. And they were never supposed to be used to be created instances because they are actually just kind of internal classes. And I'm still paying for this with GitHub issues. So if there's lessons here, it's like just be very careful about what you expose and then slowly increase the exposure if you need over time. Testing as well is something that's incredibly painful when you're doing something like a driver. So in the start, I was using simple integration tests. Take a document, put it in the database, read it back, and test, right? And I was using JSpec, and then I moved to like the JUnit clone NUnit. And then after a while, this reality kind of hit me. The thing is, like, my testing is not a linear thing. It's a grid. So I have to test against nodes 0.8, 0.10, whatever the next version is. And there's like several different versions of Mongo, each of them having slightly different features or slightly changes in behavior. And making this all work in a unified integration framework is just horrible, right? So what I did was like I had to, in the end, throw out NUnit because it didn't work anymore, and then slowly working on like a new test framework just specifically for integration testing. So the main core of the idea is to split the configuration of what you're testing away from what actually is the test. And also be able to specify tags for the test so that you're able to say this tag needs to have the server support at least version 2.2, for example, and only run it when 2.2 is present. So that you can split up your tests and run them in the grid. Right? So you want to run against multiple things. You need to be able to write a test with the least possible amount of pain, but still be able to give the runner some sort of metadata that lets it basically run it against the right version. And the other thing was like some things are really painful. Like for example, a Replicaset, like when you bring down a server, it takes a while for it to stabilize and bringing it back up. So running a lot of tests was incredibly slow, right? So parallelizing the test was also important. Not parallelizing as in running the multiple servers out there, just being able to run them in parallel using multiple processes on the machine, for example. So that's also an ongoing thing. But we all know, for example, that one of the most painful things over a long period project is that your test code grows uncontrollably because you never prune your tests, ever. How many here have actually gone back and refactored their tests and removed tests in the last couple of years? A couple of people, right? But you all know the problem, right? It's like after a while, you don't know which tests overlap in functionality anymore. And that's if you're lucky and you're only one person working on the project. I can't imagine if you're a team. So one of the things I also want to work on for this particular thing is what I call reverse code coverage. So instead of asking the question like, given an X amount of tests, what code is covered by it, I want to ask the different question, the reverse question. I want to ask, given a function, which tests cover this function? And then be able to delete functions. So this is like basically, I think I probably have about 30–40% crap tests. So if I could just delete that, I would be golden. Hopefully somebody else will be able to use it after that. The other thing when you're driving something like an open source project that everybody uses is like documentation. And we all know we love to do documentation because that's not painful at all to do, right? So what's people ask for when you're using a driver? Examples, just tons and tons of examples. Give me an example how to do X, right? And I realized that I already had those in code, right? Because I had the integration tests. So I decided to build some tools, which are a bunch of spaghetti JS that I need to refactor, and using the Python Sphinx library. And what I basically did is very simple. So I added like the metadata types myself using the, I think it's like JS doc parser. And I basically have a concept of something called class, like underscore class, where it says this belongs to this particular class and this particular function. And then what it does is that it goes down through this file, finds the doc line, which is just a line that gets added specifically for the documentation, and then basically just rips that particular piece out of it and generates documentation with using the merging in the integration test into documentation. It's still a bit like fairly verbose up there, so there's still things I need to fix. But the idea was basically simple. If I add a new test and I want to make it an example in the documentation, I could just tag it. And then at least I would have a guarantee that when you copy and paste that code from the documentation, it would run, right? So I wouldn't have to like maintain things two places. And then there's like the open source thing, right? Which is its own chapter. Backwards compatibility, right? As I said earlier, drivers need to be boring. And change is bad in drivers. Because it's not like some people are using the drivers directly, but most people are using it through Mongoose plus something else or whatever. And so when you change something at the fundamental part, at the bottom of the pyramid, the whole change ripples up through the chain, and you create a lot of havoc. And yeah, some of the APIs that currently are there suck, and I know it. But I can't change them like that easily, because there's a lot of code out there relying on it, and it's getting worse for every day, right? And then there's these changes in like just what's hot in the moment. There's hot CoffeeScript 1 week. I can remember getting pull requests. Why don't you rewrite your driver in CoffeeScript? It's like whatever. And now it's LiveScript. Like really, LiveScript? Like we're back to naming it what JavaScript was actually called. It better look like JavaScript. Then it's like the managing part of the project, right? One of the things is just to challenge people to help. Like, I really appreciated the blog post that Felix Geisendorf wrote about like just giving projects to people if you're leaving them. And I've had some success with that because I had a Git JavaScript library. It's not great, but it works more or less. And I just didn't have time to work on that, so I managed to basically just pawn it off to somebody else, and that worked great. But people in general are lazy, right? So they want to do the least possible thing. So one of the things you have to do when you maintain a project and somebody sends you a bug or something is challenge people to help, right? Try to be specific about what you need, and then like make sure that you give credits for pull requests, right? Like make sure that you are nice back. And then just ignore flames or criticism. They don't matter. They go away after a while. And there's like, just ignore bad faith issues where people are just ranting. They just put an issue there because they're mad. And I found that like the general rule is like, wait 24 hours to respond to an issue and see if they fix themselves before you start like commenting on it, because it just basically a lot of things will just go away because people didn't really try before they lodged an issue. And then your code is always going to suck. So you basically just have to roll with it. Like, how many here have actually like gone look at the code and say, "Oh, the hell wrote this?" just to realize that the Git blame was themselves? All right. So once you get that, then you understand that code and what is actual good code is completely objective and is also subjective, and it's also completely dependent on where you are in your learning process, right? So just be kind to people. That's like the general rule, and usually they're kind back. Like. And if they flame you, don't respond. Just don't. It's not worth it. And I think like as one thing I've learned at Mongo is like being good at not responding to flames. Like, so it's simple enough, wrapping up. It's like, if you're going to have some takeaways from this talk, it's like, there's no static environment. Like, we think that Node.js is fairly stable now, but it's going to change again, and it's going to have like this little knock-on effect, right? So just live with the fact that everything is dynamic. Testing drivers is extremely hard. And then don't take criticism personally. Challenge people to help you. Most people are actually nice and actually are willing to help. And just credit everybody who helps you. In fact, being nice to people pays back. In conclusion, it's been like 3.5 years since I released the code. And it's been great. It's been really busy and up and downs. And now I do it for a full-time job, so I can't complain. I made tons of mistakes under the way, and I'm sure to make lots in the future. But I would do it all again. And that's it.
Thank you, Christian. Opening up the floor for questions. It's like a reoccurring theme. I should just start on this side.
I don't know if this is reasonable or possible, but I was thinking about the buffering operations when a connection goes down.
Yeah.
There could be a configuration to say prefer memory or prefer disk, and then buffer, just stream it to disk, and when the connection comes back, stream that straight to the socket.
That's a possibility. I haven't thought about that. I think definitely something that's interesting. But the main problem with all of these options is like you have to make it very explicit so there's no unintended consequences, you know?
You definitely go to memory first because you don't want to pull out someone's disk.
Yeah. Yeah.
Any more questions? No? I like how you started that off with, I don't know if this is reasonable or possible. You know that something interesting is at least coming. Like, so many good ideas start that way. You know, I thought that was great. All right, let's give a round of applause for Christian.